I'd like to introduce the concept of rationalizing denominators. I'll start with an idea where we have a fraction of 3 over radical 7. We want to think of the number being stable or not stable. So I want to use an analogy of an emperor running an empire, ruling an empire. If 3 is at the top of the line of command, you've got this 3, which is a rational number, a stable number. And just beneath the 3, you have, say, the general or whatever, who is a radical 7. That's not a stable relationship, because if I am the emperor and I tell my first general, hey, I need you to go do such and such, and that general is a radical, they're not going to be listening to my commands. And that would become a problem for the dynamics of the empire. And so we would consider this number not very stable. What I need is a rational number in the bottom. And so what I would do, I would use a mathematician's secret weapon. I'm going to multiply by 1. But I'm going to multiply by 1 in a special way that makes this denominator rational. And so I'll multiply by radical 7 over radical 7. Now as I multiply by that, if you agree that this is rad 7 over rad 7 is 1, I haven't changed the problem, but the appearance of it will definitely change. On the top, this would become 3 times rad 7. I cannot actually multiply them, so I just group them together. And then in the bottom, a radical 7 times a radical 7, if you recall from previous lessons, that's an automatic square, so it gets out from underneath the radical, it becomes a regular 7. And this is the concept of rationalizing denominators. I started with this irrational down in the bottom, in the denominator, and through the process of multiplying the top and the bottom by this radical, I was able to basically promote that radical, bring it up top, and turn that denominator into a rational number. And so the analogy I like to use is the emperor promotes the radical, and we'll just put him in the palace somewhere, we'll lock him away, and then I get somebody that's more stable who can follow direction underneath me. And so I get 3 rad 7 over 7. This is the concept of rationalizing the denominator. Now I've got a ton of examples set up for today, so I want to make sure we understand this and all the fine nuances that may occur in our problems. So we're going to start right into our examples. I'm going to do example 1, and it's 2 over rad 3. Not a stable relationship, and so what we want to do, we'll multiply the top and the bottom by a rad 3. As I multiply by this rad 3, the top could become 2 rad 3, because I can't really multiply a free and a jailed number. And then on the bottom, rad 3 times rad 3 becomes a regular 3. This satisfies the condition of rationalizing the denominator. I'm getting a rational number in the bottom. Example 2. We've got 3 over radical 6. Now as we look at these problems, you do want to start thinking about the possibility of canceling. You always want to cancel if you can, because it keeps your numbers small and manageable. But you also have to understand the condition of how you're allowed to cancel. It's just like the multiplication. You can only cancel a rational number with a rational and a radical with a radical. So when you look at this, you may have that gut feeling of thinking that 3 and 6 reduces, but it goes against our understanding of these values. Rational numbers live in their own world, radicals live in their own world, and so you can't have that interaction. Again, it's just carrying over the analogy that we used before. The reason why we put somebody in jail is that we want to remove them from society. A free 3 cannot get to a radical 6. So I can't do the canceling there. The only thing I can do is what I've done above. I can multiply the top and the bottom by a rad 6. As you multiply by that rad 6, upstairs it becomes 3 rad 6. Downstairs, a rad 6 times a rad 6 is a 6 squared, so you just bring it right out from underneath the radical and it becomes a regular 6. Now for this second example, I'm not done because now I'm looking at that opportunity where I have a free 3 and a free 6. I'll be able to reduce those. And as I reduce those, 3 goes into 3 once, 3 goes into 6 twice, I get 1 rad 6, which I could just write as rad 6, over 2. This would be my simplified fraction. It has just a regular number, a rational number on the bottom, and it's possible that I have the radical on the top. So in this case, it's rad 6 over 2. So that checks out the conditions that I need. Let's do a third example. With the third example, I've got 15 over square root 5. Once again, as you look at this example, your gut may be telling you to cancel, but you cannot because you have a free versus jailed number. And so what I'll do, I'll multiply top and bottom by this radical. Why? Because it's not a stable relationship. I can't have a radical working beneath me. Now up top, as the numerator, I get 15 rad 5 over, on the bottom I get a regular 5. And just like in the last example, I noticed that once I released this 5, became a free 5, I do now have an opportunity to cancel or reduce. And the 15 over 5 can reduce to a 3 and a 1. And so this becomes simply 3 rad 5. Now you can say over 1, but it's just like any number. If you have 4 over 1, we recognize that just to be 4, so we just call it 4. So if this is 3 rad 5 over 1, we're just going to call it 3 rad 5. We're going to do another example. Call it example 4. This time we have 42 over rad 7. Not a stable situation. So we'll multiply top and bottom by the rad 7. This becomes 42 rad 7 over a regular 7. And then once again, I'm looking for that opportunity to cancel or reduce. This does reduce, and so I can call this a 6 rad 7 over 1, which would just be 6 rad 7. I think we can get another example in here, so we might as well do an example 5. With example 5, I've got 5 over rad 81. You don't want to fall into a rut where you're constantly doing the same thing. That's the beauty of mathematics. You've got to be able to think. It's about training your mind to think. Not necessarily all of the math that we do, it's being able to think. When you look at this problem, if you fall in the rut and you're thinking, I'll multiply top and bottom by rad 81, that is incorrect thinking. You should be recognizing that you have a square here. This is already 9 squared, so I could bring that out. In other words, I'm looking at a 5 over the square root of 9 squared. I don't need to rationalize this. This will take care of itself. I can bring the 9 straight out. And that means that this original problem is nothing more than 5 over 9. It was rational the whole time. So here we've got 5 examples to get us started. I'm going to do another video, or maybe 2 more videos, that are going to show this concept of rationalizing denominators. Your goal is to end up with a denominator that no longer has a radical in it. And these were over 1, and this is where I was able to bring a square out. Now there's actually 2 levels of this. Tomorrow we're going to learn something that's called a conjugate. Today we're going to focus on just this rationalizing denominator concept.